You would share it to people, Abi? Let's do that fast. Okay, you see, if you go online, you'll see it. Let me see if I'll find it for you.
The Nigerian Genius. The Nigerian Genius.
So your group is Nigerian Genius finalists, Abi? Abi? Alright, so I've sent you the link. Please, let's do it as fast as possible. Like 30 seconds to do that.
Nigerian Genius.
23 minutes to go. Okay guys, you have we have 21 minutes to go. 21 minutes to go. So you could still concentrate on your work. Remember, we are building a waste management system that collects waste, dispose waste, recycle waste. So you can either choose to upcycle, downcycle, recycle the waste. And you have the option of choosing either an organic waste or inorganic waste. So just choose a particular waste so you don't waste all your time. So remember that we are judging your work by how viable it is, the feasibility, how feasible it is, how innovative it is. Your work should promote circular economy, and you should be able to manage technology in whatsoever you are designing. So you should be able to, utilize technology to solve the issue of waste management. So we are in the city of Aba, and so we could use Aba as our target market. Alright guys, we have 20 minutes to go. I wish you the best. Right. Okay, so when you are seated, quickly choose one person from your team. Remember, you're doing a 3 minutes presentation. You're going to present your work, what you did. So choose one person from your team to do your presentation. Now, of course, I listed the judging criteria. So while the person is presenting, you should also bear these things in mind. So you tell us how visible. Of course, we should be able to decode that. But of course, while you do your presentation, tell us how visible your project is, how viable it is. Tell us how you leverage technology in solving that problem. Tell us if your problem promotes. Of course, we should also be able to decode that. Your project should promote circular economy, should be innovative. So each team has 3 minutes. So once we call a team, just the person that was selected to do the presentation comes out immediately. We are starting FUTMINNA. So the judges will come to your stand, then your team representative do your presentation. Remember, you have just 3 minutes. So time.
Yes, sir.
Okay, good morning. I'm Abubakar Musa Omara of the University of Technology, Minna. Our design here covers plastic recycling process and manufacturing. It's two-phase processing. We have waste collection. The first screening of the waste. We screen the waste. Secondly, we crush the waste. Thirdly, we dry. Because at the point of screening, we have to have wet moisture. Then we recycle. That is the conversion to a pellet. Then output, which is this output, a pilot product. Then we put a flow chart here to show the series, these steps, how it's supposed to flow. Then the second step is waste collection. Then in waste collection, if this plastic, if it's not the type of plastic we need, that is in the screening step now, if it's not the type of plastic we need, we're expecting the process to go back to start. It's an algorithm. Then if it is, we continue the process. Yes. Then we come to screening again. Then go to unwanted. You know, after screening you have some unwanted. Then these ones we dispose them. Then the real one that we now want will be crushed. Then from the crushing we dry because of the moisture content. Then we now recycle. This is where we come about the extrusion machine in order to convert the plastic 1 minute remaining into this.
That's the first phase of the production for this. So we have another second phase after the final product. So this is manufacturing process. So the manufacturing process now, the final product, fillet, this fillet here for the output. Then from final product we go to extrude machine process, which is converted to bottle, element, pallet or plate. Then from extrude to package, just to beautify your item. Then to storage, warehouse. Then from storage to supply. So after we distribute it for human uses and economics, just to boost the country economics. Then after human uses now, they will dispose it back. So as for disposal, then go to waste collection from this.
This is our workflow diagram. For the recycling, this is utility, recycling, manufacturing, and final product.
So you were supposed to show us how you collect the waste. So how do you intend to collect your waste?
You can see from the waste. Here we have waste collection. From this place we can get the waste from scrapyard. Even Ministry of Environment, when they collect waste, generally they want to dispose it. We collect it from there. We can like kind of partner with them. Instead of dumping it and burn it as a waste completely, we now receive it and convert it into something. So now these are the plastics. That is the waste we collect. And this is the screening where we remove the unwanted particles. This is the crushing unit where we convert we chop it into small layers. Then from there we dry, as I said, we dry the process because of the moisture that will be mixed during. Then conversion. This conversion is the recycling point where we need to convert it to a pilot, like a raw material. And here is a raw material. That is what we have collected. That is, we have bring it together now. Now, that is the output of this place. That is what we have here. Then the manufacturing process. This is where this process covers. And we have final output. That is the human use from there. Then it go back. You know, after human use again, they dispose. And we collect again. Then it go back to the waste.
And what is the circular economy involvement here? Anybody can answer?
Yes, if you look at our cycle, this is like the recycling cycle. This cycle now starts from waste back again to waste.
Looking at your flow diagram, your flow charts.
Yes. Okay, so very much. This particular something, I don't think we have much challenge, just that time.
I think what he was trying to ask is on the issue of challenge. Like, is this still something that, assuming it costs, let's say, 10,000 US to implement, is this something that once that amount of money is given to you, you can go to the market, get the machine, and implement? Like the machines, the extrusion machine, what you need to implement this circle, this process, is it available?
Yes, it's, in fact, everything that this process need in Nigeria is available. Everything. The only thing that might be constrained is utility, you know, like power supply. If it's like water, we can't help. The major challenge, and that is a country problem.
So team ABU, who is representing your team? Remember, you have 3 minutes for your presentation. We'll move to Q&A.
Hello, good morning everyone. I'm Ibrahim Bello. I'm representing Team AB Zaria. So here we have our waste collection, waste management system. We actually developed a very simple one that be easily executed by any group of people or even industries. So it's a zero carbon emission waste management system. We actually make a kind of format that we are not going to burn anything. Everything will be disposed. If we have any useless or unusable product, it's going to go through biodegradable process. So we begin from here, collect our waste by classifying. We have a container that we're going to use. So that container will actually label electronic waste to specify that kind of waste for the people. They'll be labeled on the container electronic waste, sewage, that's liquid, gas and other products that are not solid. Then here we have our solid waste here, refuse, inorganic and organic. Although the concept here is that we will actually be having some of the products that's supposed to be here, they will dump it here. But that will be sorted out at the factory. So from there, our logistics systems around this area. So we'll get, there's these people they call Yahoo boys. Although it's not Yahoo boys, there are people that will all together, we call them for training. There are 2 or 3 month training on how to get this thing picked at factories, industries and residential homes. So once we get that, we would like less than map it into geographical regions like 6 or 10 so that we can actually put them together. Once we put them together, we can use 6 or 10 lorries, bring them into the factory each and every day. So once we get that done, then we'll now go to the factory where we conduct our classification and recycling as well. Because for you to actually manage waste effectively, you need to do something that we call classification and processing. So once you get that your classification and processing right, then everything is done. So for the electronic waste, once we disassemble them, then we further classify them into metals and non-metals. Among the metals, we have precious metals, which are like gold, silver, molybdenum, many other precious metals. Then after that, we'll do the recycling. In the recycling process, for the e-waste, we actually have the board for our advanced recycling section, where we'll do that one. Then as for the rubbers, we'll further classify them into polymer, liquid polymer for the e-waste. We use that one for IDP camps and refugees to help their life, at least upgrade their standard of living. Then for this one, we use the sewage gas for cooking. Then as for this, we use it for fertilizers and farm produce. Okay. All right, my time is still on. I still have some seconds. Okay. All right. All right. Yes, sir.
And then you said further recycling.
Yes.
Further recycling. What actually
this
happens
place,
there?
This place, I actually missed something out. Give in the marker. This place is our disposing process where we do the disposing. So what we intend is that actually there's nothing waste in life, because it is said that energy can neither be created nor destroyed. So in this whole process that we are living, even in London, if you go to London, the water you actually drink is still the water you use in your toilet every day. The water you use in your toilet actually goes back to a central place where they can actually recycle it for you to actually take again. So everything is a process. So instead of us saying that we are disposing something, we are not actually disposing anything. What we are doing, when it gets here, we further take it back here. Anything that is usable here, we take it back here. We process it here, and then what is not useful at all, that we feel is not useful, can be used as polymer for foundations of buildings, like very timid rain tropical areas like this place. When you put some interlocks, you see plants growing, so you can use some of those polymer materials to floor the foundations. You get?
Yes, just I'm not trying to stop you, but I want to find out, was the specification, were they specific on plastic waste or?
No, this is a general waste.
Yes, whichever way, whether
it's a general waste, management for general waste.
Sorry, what waste again?
I said general, for general waste. Organic, inorganic, electronic waste. Because the reason why we intend doing this, if you leave this electronic waste out of the equation, these are the most dangerous to the surroundings. Because when they get to our drainage, they end up going to our riverine areas, the seabeds and the oceans. So they kill animal. You know of lead poisoning in Zamfara that happened. And these things contain gold and lead and silver and the rest. So it causes lead poisoning to the whole society. Not even the human beings, but the animals too will be affected.
Okay.
Yeah.
Okay.
And then your title, zero.
Yeah. Okay.
With your flow.
Okay, the reason why we said zero carbon emission system is because the dangers that have bedeviled the global village, when you born, like we don't want to light anything at all. You know, if you go to different kind of waste havens now around the countries, you see those people that do things in an informal manner. When they end up taking the gold out of any waste product, like what I mean by the gold, if you keep a voltage regulator here now, the gold in that voltage regulator is the copper wire, the copper and the iron. Once they take it, they finish taking it. Anything polymer there, they will take it to waterside or some junkyard and burn it. So burning it, those things contains high carbon emissions and they damage our ozone layer. So instead of doing that, why not use organic degradation or chemical process? So that's what we are doing here. Once we found out that those things are to that part, the last stage, so we take them to this place where we do chemical and organic degradation so that we will not have to cause any harm to the ozone layer. So we use chemical process, half-life, now nuclear way. So we use those things to bring about new materials from there. And those materials that we get here can actually be used for IDP camps and refugee camps. Once we put them together, I use it to make houses or other usable things for IDPs and refugees. So it's a kind of the kind of that economy that we actually demand for global peace.
Let's for clarity's sake, let's focus on electronic waste, right?
Okay.
Because it will make the entire thing ambiguous.
Right.
Because if you're managing electronic, sewage, liquid and gas and all
But
of
it's
that.
possible with consultants. Once you have consultants around.
For the purpose of
Okay.
this particular assignment, yes. So let's focus on electronic waste. So if you're collecting electronic waste.
Okay, all right.
Yes.
Yeah, carbon
Yes.
emission.
So let's get the flow. So you collect it. Your collection detail was very amazing. So you collect the electronic waste, and then you do the dissecting. The disassembling.
Yes, disassembling and further
Disassembling
classification.
and further classification. So what do you recycle it to? You recycle it to polymer.
Yeah. When you get here, from the classification alone, you recycle it to aluminium, copper. Aluminium are used in almost our everyday life, both informal and formal sectors. Then for the copper, you also give it to those people that use copper cables. We can make copper cables and other different kind of copper implements.
Okay, so I wanted to get. Okay,
then
so you.
For the board, they need advanced recycling system whereby you bring machines that can actually extract gold, silver, molybdenum, radium, and uranium. Those ones will be another separate assembly.
Okay.
Yes.
All right.
Giving all necessary materials and resources.
Yes, sir.
You can use it to treat the sewage like Abana. You can use it for Aba.
We can actually do this in Aba and then replicate it in Africa and West Africa and Africa as well.
Okay. Okay.
So our own waste management system, we'll be talking about the biogas system. The biogas system is a kind of waste management which we convert waste from humans, like the excretion from human, into something useful, a useful gas, a methane gas. So we have a design here, which the excretion from the human comes to the waste collector. Obviously the toilet, we all use the toilet. So we collect the waste from the toilet, and from there it goes into the sewage system, where we have the decomposition process happening to it. We have the microorganisms in the sewage system working, feeding on the waste. Then from there, we know that when we decompose any waste, we have the remains, like the matters. Those are the ones that settles inside the sewage. Then we have some gas that escape. So those gas that we escape from the sewage system, we have a gas extractor attached to the sewage system to collect those gas. And we know, obviously, those gas, we have some contents like the moisture, the other unwanted gases as well. So we feed that collected gas into a filter chamber where we separate that collected gas into the useful gas we need as methane, and that methane gas is stored into a gas cylinder, which is as ready to be used in that stage. So from this stage here, you can either use the methane gas with a generator, which we can use to generate electricity that can be used by human. We can use the electricity to power our house, and obviously the humans are the ones using the appliances in the house. And as well, we can also couple that with our gas cookers, stoves and stuff. We can use it to cook. It can be a form of energy which we can use for cooking, and as well we can sell that gas to make revenue. So our waste management system focuses on four major stuff, which are generating of electricity, also revenue. We can sell it to generate revenue, as well as it can be used for employment, because you don't just go to market and buy a biogas system and install. You need an expert, because you're dealing with gases here, and any form of mistakes, it can be very disastrous. So we use you need an expertise, someone that is well experienced in that field, to help you construct this system, which you can use as a form of so here we have the block diagram which human waste to the storage like that. So
that's a very good aspect. Tell animal dung could have said
I'm considering our environment in terms of this human waste because okay, I just want to I'm considering our environment because when we talk about animals, we don't have those animals available, but we have humans all around that obviously they use this can be animal waste, human waste, and other kind of waste, but not the inorganic type.
So for
sewage collect, you know, where you have what you put there, system, that system.
Yes, sewage system.
I want you to say whether yes or no. Will that be likened to the septic tank or what?
Yep, that is like the septic tank because in the European world, most of the countries that they use this large chamber for waste collection, which they also recycle to generate their electricity, stuff like that.
For in our own context, for what we have available,
yes, sir.
The type of sewage system.
Yes.
So it's
yes.
We don't
yes.
build. You intend to cut your gas extractor to that type of sewage system?
We first of all have to inspect the kind of sewage system we have there and ensure that there is no point of leakage of gas at any point. Then we bring in our gas extractor, because when there is no leakage and you have more inflow of waste and there is more decomposition, at some point there will be this pressure in the tank, which will make the, so if we have a gas collector connected to it, obviously those gas in the sewage system will escape through that channel, so other decomposition gas and decomposed gas can also come into the sewage system. So it's more of like an input-output system.
So what I'm asking is, you missed the question. I said, you mentioned septic tank and all that.
Yes.
I said, in our own context, what applies to us? You know how sewage system is designed and built here? Like it's an underground stuff. How do you connect your gas extractor to it?
We use pipes to feed. Yes. It can be on top, it can be, depending on how we want it to be sealed.
Your system is okay, but what I want to ask is, can we convert the present sewage system?
Obviously, sir, we can do that.
Okay, if we are to convert, is there any catalyst we can use, or is it a normal thing? Just connect a pipe and we start having gas in the other side?
We have some catalysts which we can use to fasten the rate of decomposition. We can use that to make things faster.
Okay, thank you.
Hello? So on the labor force, do you have some special trained personnel for this system to work?
Sorry, sir.
What type of labor force do you have to get this thing done? Do you have special trained, or you can use any type of labor force to get this thing done?
No, we have people who construct this stuff, because you are dealing with gas, and if gas is something, if you don't handle well, it can escape. So you need someone that is an expert in this construction that can help you achieve that, because you can't just bring anyhow person to come and do this kind of, there will be a lot of damages. And most especially at this stage, you are dealing with flammable gas, which if you have any form of mistake there, you might not have the chance to repeat it again.
That means you need a trained.
Yes, sir.
Not
yes, sir.
Okay.
Yes, sir.
I'm looking at your flow system.
Yes, sir.
Methane gas. Methane gas, the usual output from the sewage system.
It's not always we have a mixture. That's why we have a filter here. Methane is part of what you can get from a sewage system. So we have a filter here which separates that into different.
So actually, separator or filter is that you have something like hydrogen sulfide, you have nitrogen, you have all this. So you now extract it,
yes, sir.
And then from what you were saying about the methane and then leakage, that
yes,
means
sir.
it has to be airtight,
yes,
so that it doesn't, because if it leaks and then there is ignition, it will cause fire hazard.
Yes, sir.
And then for the hydrogen sulfide, if it leaks to people, it will bring bad health problems.
Yes, sir. Yes. Yes. Most of the ones I've seen they constructed here, like some of my friends have worked on, they use a tire tube which they feed in the gas into it, and the tube can hold. Yes. And the local.
Good morning, my judges and my co-contestants. Good morning, my judges and my co-contestants. We are here to explain what we've done so far. As people from the riverine community, Akwa Ibom in particular, we are bedeviled with something, plastic waste. So plastic waste has been a major problem, even in the upland. In the sea, it affects the marine life. You can see even the fishes, they swallow it. And we humans, at the end, we eat up those fishes, and we have at the risk of having one problem or the other. Then even on land, you see building collapsing because of plastic has been filled on that land. So sometimes it becomes somehow elastic, sometimes building collapsing without a good foundation. So we came out to solve a problem by managing our waste, and now we focused on LDP, low density polyethylene waste. So now on our waste we have a mixture of, since it is plastic, a separation from the bin. So we have the low density polyethylene, we have the HDP, which is the high density polyethylene. So you have other debts involved. So but now we collect. After collection, we have to select. Selection process, you have to take out what we don't want, then move to the point where we start processing. So now we go on to compact the LDP we've gathered. From compacting, we heat. Now heating now is to actually make it to coagulate. So now from heating we go to molding. Then from molding we form a billet. Now let me come to this other side. Before we started, the problem I've said is about pollution. So we actually did our background research. From that, this is off the line. We thought about it. We brainstormed. We developed a prototype. Then, if we test, if it doesn't pass, we have to go back to first principle. Now we made an illustration of what we want. We considered several factors, which is viability, feasibility, technology, innovation, and to promote circular Nigerian economy. Then we consider safety, which is paramount. So now, if we want to check the industrial, the manufacturing part, so from here we have our collector where the waste come in. On this point, we have a sensor. This is a level sensor. When our waste is up to the level, this sensor will give an information that that this opening here, this port here should open. It opens, then it moves now to this conveyor belt where we have sensors also to pick up metallic waste. This sensor will send message to this robotic arm to pick out the metallic waste and put in this bin. So as it's moving via this, through this conveyor belt, we have another HDP sensor. It picks out the high density plastic. So it picks it and put in this waste. Then our LDP progress to the compactor where it is being compacted, form into a shape. So we still have another conveyor. Now on this point we have a weighing scale that will weigh what we compacted. If it's up to the level, then it moves. Now to this point, we've the compacted plastic. It moves now to the heating chamber. The heating chamber where it is heated and becomes liquidous. At that liquidous point, we have it flow into our molding chamber. It forms the mold here and creates the billet or the product. Now for the common man, you can see this what we choose here is an hypothetical design. Hypothetical design.
It's going up now.
Okay.
Time is up. So maybe why there are questions, you can now clarify them. So if they understood your still trying to grasp.
Okay. Okay, now I was saying. Okay, yeah. I was saying it's an hypothetical value capacity. So now we came to this point, the size of compaction. We considered anthropometrics, the size of a regular human being that carry weight at this point is 50. Our billet to come out at this 50 by 50, 50, which is 50 times 15 to 3, which is 125 0 cm cube. So we made that volume. So we considered weight, so that even when our machine, our forklift is not around, human being can pick it up. You know, at 45 kg, we consider a regular, a standard man that can pick this. So with this, if you can see, we also move to the point where if we sell this out, it can be used to produce nylon, water bottle, buckets. So like you see on this point, it can go back to collection after being consumed and disposed. Can go back. So these are what we have. You can see the engineering now. A common man, this will give job to everybody.
Is it just within this 45 minutes you'll be able to conceive it? Have you done it earlier?
No. They are mechanical students, so we know what we're talking about. The mechanical students.
Yes, I have seen a factor of safety. Can you explain what you intend doing there or what it implied?
Okay, the factor of safety, why we chose 1.5. If we choose 1, that means we are producing the same thing we have here. We made it so this 5 here, 0.5 is like adding an extra half. So if at this point the thickness should be around 2. Now factor of safety we use 1.5 times that to make it 3, so that it will withstand what we are compacting. If at this point our flow rate is 0.005 meter cube per second. So at this point we need to consider extra, because once we flow faster is not melt inside this tube here. So we consider factor of safety. You know, because as engineering student I said now who they are alive is genius. So we don't have, so the sensors here are still our safety systems. They alert us so that it will not overflow and still go back to the environment again.
At your measurement, you know, your notation, meter and meter cube, you know, at least you cm cube and then meter cube. I think it's better to use one. It's either you are using cm cube or you are using meter cube.
Thank you, sir.
You know, thank you.
What is the heating chamber? What is your choice for using 310 degrees? You have different components there. Which material are you expecting that?
It's because it's a low density polyethylene. So at 310 degrees Celsius, it will melt and give us that liquidous point. So we don't want to take it so high at 500. It will start breaking, then evaporate. If we take it below, then at that point it will not give us the right liquidous point. So we have to melt it to that point so that it will flow.
A follow-up. Were you able to get can you say the melting point? Can you, from data sheet or whatever, you know, information, is it possible to say this high density polyethylene has a melting point of so and so? Did you get it somewhere, or you just use 310?
We've done materials before, so we actually pick it from our previous class of materials. So we chose this value so that it goes well. If you take it off, that means you are going for HDP.
Generally, as they are doing this, I hope they are also permitted to browse any constant. Okay. So it's all right. It's all right.
So I remember. And implement.
It's viable, just like the robot we are about to produce. It's viable. You know, every robot, you know, we have been asked to produce a farming robot. This one is even a smaller system compared to the farming robot. Just send a sensor, the robotic arm, to pick when you notice it, then drop it in here. So with AI, Arduino, we make it just like we want to produce our farming robot. So we don't have to outsource it. We do it here. This is where the implementation man, the computer engineer, the electrical engineer, the mechanical comes, because the mechanical will do the framework, electrical will do the wiring, then the computer guy will do the programming. So the team will give job to every Nigerian. Every Nigerian, the instrumentation guy will have a job from the sensor. Then the common man will be selling this billet to industries where we have it while we are depleting the pollution in our environment and saving lives of marine lives and human lives. We are picking plastic waste. So we have what they call waste segregation. Okay, yeah, okay. We have what they call waste segregation. You see containers. You see this one is metallic. This one is plastic. And so at that point, some people will always want to go and put the wrong one in the other container. So this will not always control the outcome. So now that's why we took the plastic one. Then we know we are expecting some element of metals, because some people and some waste also come with metals, like see plastic. So at that point we want to separate them.
Hello.
specified over 120. Our average is over 120. That is a FUTMINNA and ABO. They run into the third position. Then the second.
Let's clap for them first.
Then the second runner-up goes to. Yeah. So like I said, I have to appreciate all of us for the wonderful output from your text period. So it's time for us to read out our various scores. FUTMINNA had 85, about 120, and the ABO equally had the same grade, ABU, 85. So they come in third position in this competition. Then followed by UNIUYO that had 101. He came in the second position. It becomes obvious that the Polytechnic had it with 102% coming out in the position of first. The rest is a teamwork. Congratulations to you all.
So YABATECH is next.
YABATECH. People do not, you will not clap for yourself very well. But we all had amazing. I think today's brain teaser is like since we started this brain teaser, today is very exceptional. Like you guys had to put on your thinking cap, and within 40 minutes, you came up with very amazing design. In fact, I was super impressed by UNIUYO's design. UNIUYO came second, right? I was very, like the way you did, within 40 minutes, and you went with your devices, no phone, no laptops, did the calculations, the robots, the said everything was flying up and down. It was super impressive. Like we brought geniuses together, and then all of your designs are very beautiful, very amazing. So for UNIUYO, for YABATECH, please step. So
you guys are not smiling. I'm impressed. So I have to hand over the 10 points to you at the cost score during the Nigerian Genius final. So,
please let's celebrate them for the last time. So remember all of the yardstick that I listed out before we started. So don't know that they have the beautiful design. The other team, you guys had amazing design, and of course I've indicated my UNIUYO's design is very amazing. But I was super amazed. Like I told you, all of you, like 40 minutes, I've seen, maybe my next one, I'll be an engineering student. So I'll be doing calculations like this with CM and steel shoes and all of those things. So all of your designs are super amazing. Then again, of course, remember we mentioned viability, feasibility, of course, yeah, circular. In fact, for this particular YABATECH's design, I was just sharing with them. I know a friend that is into this full time. He owns a very big startup, and he has won a number of grants, recognition, even from the past vice presidents, just with this. So, but for his own design, he even pays you when he collects the waste from you, and he turns it into biogas, and it's something that you can take to the market, and implement, and Like it's very, very visible. That doesn't mean that the rest of your designs are not visible. All of it are very visible, but YABATECH's design stood out for the judges. I was not, so I hope you will not be any grudge against me. You know, just 1 point. Like, just 1 point. I was even advocating, like, they should die. There should be a tie. It was just 1 point, but you guys did amazing. Like, you guys did beautifully well, from FUTMINNA to ABU to YABATECH, and you guys had very beautiful design. The plastic recycling. Now, listen, these are things that you can actually implement. Most of us have started businesses that we picked up ideas from such activity. Like, you can, as a team, as your team, you can start up something like this. You can bootstrap, have a proof of concept, apply for grants, apply for investment, and you get funding. For, like, this is very viable. If you're able to recycle waste, then recycle it into PESPET. As you said, PESPET. Sorry, filament, right? Oh, beautiful. I'm an engineer. Small. You said pilot. Okay. So you can turn it into something like that, and then I think I saw somewhere you wrote filaments. Is it the same thing? One of the outputs, and I know that even here in CIC we do a lot of 3D printing, and most of our filaments are imported. Like, we depend on China and the rest of the country too. So this is something that if you implement it, we'll buy filaments from you and other outputs, and you can grow it into something very beautiful. The same applies to ABU. Sorry, let me come closer.
Yeah.
The same applies to ABU. We generate a lot of electronic waste, like a whole lot of electronic waste. And it's something that if we're able to recycle it following this chart. Remember I said you as a team, the three of you as a team can, because you didn't get it, it's just 10 points. I hope you're not angry at me. I was not among the judges. I didn't. So remember we had lots of ties, and the points were very close, like we had lots of ties. So this is something that you can actually take to market. So you as a team, you can start up something, bootstrap, have an MVP, even if it is an MVP, a minimum viable experiment, a minimum viable product, seek for funding, take this to market. Of course, there are a lot of world conversations around zero emission, clean energy, zero to waste to raw materials and all that. So all of you have very amazing designs. And then UNIUYO, I'm super impressed. I think it was the calculations. The mathematics. A lot of us run away from sciences because of mathematics. Once you hear Pythagoras theorem and calculus and the rest, we ran away. So, but you were able to do all of those calculations in just 40 minutes. It was super impressive, like super impressive. So congratulations to you guys. Today we should have given 10 points to all of you. Maybe when we discuss with the judges, it was super. What they did was super impressive. Like, I know I'm a business owner. I know the process of ideating. Like, to come up with an idea is not something you just sit down and then do over a cup of tea. So I know the process of ideating and then coming up with something like this. All right, guys. So, Mr. Promise, please, you can. Are they going for a break?
Yeah, we are going for break. 5 minutes. Then we continue for the presentation. 5 minutes break. Okay, let us be 15 minutes. 15 minutes. 15 minutes. 15 minutes, please. 15 minutes is 15 minutes.